Okay, so during this video, we're just going to be working on improving this enemy that we made in the last one. So, that brings us to the first thing I have to cover is I'm not sure if I went over this last time, but in the clone script we need a func receive damage and pass in the damage amount, damage type, and all of this stuff. I'll let you have time to copy and paste, but also need to do current attack is equal to null. So if I did do all of this, just double check that you set current attack to null after you Q3 it in this function. And if I didn't do that, then in the player script we should have no, not in here, in the attack script we should have this. We've got our clone and I want to make some adjustments to them. For one, I want to lower the max speed. Let's try 600 for now. It still seems a little high, yeah. Maybe increase the acceleration to 900. Change this to 5. No, let's say 400 even. Still a little high. Let's change this to 200. This to 700. Oh. Did I please find current attack dot Q3? So we only have one match. We set current attack equal to something. So got that and okay, so in here. So that large melee ends up destroying itself after a certain amount of time. I gotta declare a function first. Let's say func remove attack. Alright, pass for now, and then in our animation player right before Q3 we're gonna put in our remove attack function. And let me zoom in on this text a bit, it might be a little hard to read. We're gonna have our, where do they do this? Receive damage, this amount. Let's do func remove current, actually no. So they add the child to them, so we're gonna go get parent dot current attack is equal to null, but we only want to do this if we are an enemy, because the player doesn't have a need for this. So if it's enemies is equal to false, then we'll do this. And I'll see if that works. And we just want to player. Yeah, so the main goal of that was just to make it so that if the player hits the enemy and the enemy is trying to attack them, then the player will not get hit from their attack. So it's like an interrupt. Anyways, you can go ahead and close that scene, go back into the clone. Now we need to make it so that, let me just open this. Got a weird thing, you know how they can kind of like jump forward in the air a bit? That's because we've got that thing where if we're in the air, they'll move around slower, and then they can kind of move closer to us if we get far away enough though. So then we gotta change that in our moving script. What is it called? Check can advance? Yeah, so we'll do and on ground is equal to true. And we'll just copy and paste that into here. And I believe let's test that out. Nope, they're still moving. We'll also want to copy and paste that into here. I'll check where it goes. And do lf that, and then we just gotta delete this and function, not function. And this should work, hopefully. It doesn't appear to be working though. Let me change this back to something else. Let's delete both of these. Then do if on ground is equal to false. Yeah, let's test this out. Still not perfect, but it'll be good enough for now. So we're gonna need to reopen our melee scene. So then use shortcut keys. If you do Control Shift Tab while you're in the 2D view, it'll open your last 2D scene, and if you're in the script thing, it'll also open your last script if you've closed it. So we're gonna go into this script, and we are going to change this so then if its enemy is true, value dot is equal to enemy. Then we do lf, that happens. Then we're going to do the same, copy and paste that. But now what we want to do is make it so that, actually no, wait. Yeah, let's do this. And then now what we want to do is do local body dot global position dot normalized, and declare non-ready variable of our, let's call it rebound direction is equal to that, and rebound direction times equals -1. So that way it's the opposite direction we hit them, but it would be best if we made it so that the player could always go up from that, and it just switches the X from the direction it's supposed to go. So we'll do if rebound direction dot y is bigger than 0, so if it's going down, then we're going to times it by -1, so it now goes up. Then we're going to get parent dot rebound, and then do rebound direction. So now we need to go into the player and make another function, func rebound, rebound direction in here, and we're going to set motion is equal to vector 2 0 0, motion is equal to rebound direction. Actually, we can just take this out because we're declaring motion is equal to this here. Let's just do times 60 for now. We'll move that into a variable, but let's see what happens here. We get a small bounce. So yeah, let's go up, and where do we want to put this? Probably right after here. We'll go rebound. Speed is equal to 100 for now. Let's change it to 200 actually. And we'll change this to rebound speed. And now let's just test it to get something that works. I think if the player is going to be approaching the enemy from underneath, it's good to have that X change the direction, because they'd be going up and then they'd continue to go up, but they'd knock off the other way. But when they're on top, knocking them back to where they were feels a little off. So what we're gonna do is change the code of this around a bit. So then delete this. Now our rebound speed .y is always going to be -1, but our x hasn't changed. So if our rebound direction is above us, so then that means it would have to be negative. Then we're going to change our rebound direction .x to the negative of what it is. And I need to change this to .y. And let's see how this works. Yeah, so now it just gives us more boost. And get them more in the center. It seems to only be working half the time. Actually no, I think this needs to be here. Let me just see what that does. No, I think we need to, I think it would be best if we just passed the body's global position into the player, just because the melee can spawn quite a bit farther down inside of the enemy. So I'm going to go into our player and rebounder's position is what we're going to change this into. So then var rebound direction is equal to rebounder's position, sorry, to local rebounder's position dot normalized, and if rebound direction dot y is bigger than 0, so if it's below us, then we're gonna times our y by -1, and rebound else rebound direction dot x times equals -1. And let's see what this does. Yeah, so this is a lot more consistent. And it's a little strong though, you know, like the player can get quite a bit of height off of this. So we're gonna have to reduce that. But yeah, they could get up there anyway with their dash, so having it that they can get practically up there while damaging an enemy is good. Because if we make it like that they can go the same distance as their dash, then dashing while not hitting an enemy is no longer like a way of movement. It's like hitting an enemy becomes more convenient for platforming and combat, but if we have it that hitting an enemy downwards to get the rebound is convenient for platforming but more convenient for combat, then dashing while not hitting an enemy is more convenient for platforming but not for combat. It just allows us to separate the actions a little and we can make some cooler level designs out of them. So something I want to do is, what the normalize does is it changes it to a value between 0 and 1. So then, right now when our rebounder's position gets normalized and the Y is pretty high, we can get some pretty big values that make it kind of hard to use our rebound speed properly, because we can have 0.1 or we can have 1, and you know, there's a fair amount of difference between them. So what I'm gonna do is I'm gonna make it that if rebound direction dot y smaller than negative 0.8, because it's now a negative number definitely from this, and rebound direction dot y is equal to 0.8. Let's change this to 0.7 actually. And if rebound, actually I gotta move this else function up to here. But yeah, so then if rebound direction dot y is bigger than negative 0.2, got to make this a negative, then we are going to make it so that rebound direction dot y is equal to negative 0.3. So let's change that to 0.3. So now if we try it, can't get too high off of them, but we're also getting a more consistent height than beforehand. I think I want to make it that you can get a bit higher off of them though. Yeah, so we're going to increase this to 0.8 and this to 0.4. So it's close to our dash, but not quite. Yeah, that's pretty good. So now comes the point where I should have done this a while ago actually, probably with the first video, but I don't know why I decided not to. But I need to discuss what this video series is actually trying to do. So when I first started learning programming, I found myself wanting for there to be a tutorial series that was free, that could take you from just having nothing to having a full game you could release. These would just be pretty useful, you know? I could learn a lot from it, and there was just so many missing pieces to trying to figure out how to make a game that I had to figure out on my own, and it was pretty hard. And so that's what I'm trying to do with this, and it's happening very slowly, which I would like for it to happen faster, but these videos just take a while to make, and I don't have too much spare time to make them. So it's just gonna happen slowly, but hopefully, eventually, in a year or two, it'll be done, and it'll teach you how to make a full game. And what is this full game that I'm trying to make? I decided to call it Possession, because that's what you're gonna do in the game. You're gonna be able to possess the enemies that you fight. You'll notice that the player has a mask, and the enemies have a mask, and that was done on purpose because you're going to be able to use your mask to go onto these enemies' bodies and possess them, essentially, and gain some of their abilities. And that's a fairly advanced mechanic. It's not too advanced, but like for a free tutorial, it's uncommon to find too much stuff like this, which I think is pretty good. It'll, even if you don't plan on wanting to make games that have mechanics like this, being able to see how this system works, even if it's not the most efficient system, and I made it, so it's probably not, but it'll work. But yeah, being able to see how it works is going to help you be able to look at programming from a bit more of an advanced perspective, so that hopefully you can come up with your own systems for slightly more advanced things similar to this. And yeah, so that's what we're doing for this second half of the tutorial, is setting up the enemy to be able to be possessed. And then in the next tutorial I'll try and make it so that you can actually possess the enemy, just because there's lots of steps to take, and yeah, it'll just be a bit. Okay, so now what we need to do is make it so that the enemy can die, and I need to check what animations do we have. Die, idle, stunned. What does stunned look like? Okay. I'm gonna need to make some more sprites pretty soon here, probably halfway through this tutorial. But for now we'll set it up so that the enemy can die. After this part, we're gonna go health minus equals damage amount. The damage type doesn't matter. This enemy isn't gonna have any form of resistances, though future enemies might have some resistances. So health minus equals damage amount if health is smaller than or equal to 0. State is equal to stunned. That's basically, I'm gonna make it so that you can only possess stunned enemies. And when an enemy reaches 0 health, or maybe if we get some other mechanics, then they can be stunned. And after a certain amount of time of being stunned, they're just gonna die. So they get stunned, and then we're gonna need a stun time variable. Not variable, timer node. Stun time. Set it to 1 shot. Let's give the player 5, no, it's 3 seconds for now. Connect the timeout, and just gonna move it. Where should we put it? I'm gonna put it above the walk dust to create delay. And at the end of this, we're just gonna set state is equal to dead. Do we have a... yeah, we have a die, which then just makes them disappear. Add a call method track to a clone, and they are going to queue free at the end of this animation. If state is equal to dead, let's go into our animate. So then elif state is equal to stunned, then animation player dot play stunned, elif state is equal to dead, animation player dot play die. And we're going to make an quantity variable for stun time. And here we can do stun time dot start. So I'm going to go into the player, and I'm going to go into wherever their attack function is. What do we set it to 5 for now? Yeah, we do. So that's enough to one-shot him. So that's good for testing purposes. Okay, so it seems like he's just continuing his physics process even though he's in the states, in a different state. So we went to physics process, state is not equal to dead. We do else update on ground, animate. Does update on ground apply gravity? No, that's fair enough. Remove this. To here. We're copy pasting it, sorry, we're not moving it. We can keep this here. So I copy paste it. Then we're also going to say that motion.x is equal to 0 whenever this happens. Motion is equal to movement slide. In fact, we'll just backspace this, backspace so that it's outside of this else function, and then we can delete this as well. And we'll do the same with this. You can press shift and then tab, and it'll move everything in it back one. Should we do the same with this? Yeah, let's just do it. And then we'll space that out a bit. So if state is not equal to dead, we don't also want to do and state is not equal to stunned. Then hopefully it should work now. We need to start to stop the timers, I believe. So we're going to go into our receive damage, and we're going to go attack delay dot stop attack time dot stop charge delay dot stop. Now let's see what happens. Okay, so they die repeatedly, and then they get deleted. I just need to change it so that I just go into our clone, and then a simple way to fix them from repeating the animation is just to make it really long after it plays that, so we'll make it 10 seconds long. That way we've got some wiggle room in the future if we want to adjust the stun time, then we don't have to go back into that and adjust stuff as well. And now they're not taking damage. Okay, no. No. I just want to check if we're really killing them straight away. So I'm going to go print high. Yeah. Maybe try that a couple times though, because yeah, they're getting back up sometimes, which is definitely not what we want. Is that because the player might be going into their attack range and that's changing some stuff around? It is. Yeah, so then if state is not equal to dead and state is not equal to stunned, I'm just gonna drag all of this and click tab so it gets pushed forward. Then we do that stuff. Let's just double check the attacks still work. Yep. We kill them. And everything seems to work fine. Actually, let's make the mask. So we have a kinematic body 2D. I'm gonna call this enemy mask enemy mask object, I guess. I don't know, there's not really a good name for this, but save it in effects. You can add a sprite. I'm going to add a collision shape 2D. And let's go into our assets, enemy mask, drag it in here. We'll get our collision shape to be around this. Let me change it to 2.5. Yep. And I'll change this to 2.5 as well. Okay, so we got our collision shape, our sprite, and now what we need is a raycast 2D. So rename this to ground cast. Enable it, so 1.1, say 2.1, and we'll move it down. Yeah, so this goes, no. Oh yeah, because we have it at 2.5, so 2.6. Okay. And now, we're glad to just that there, sorry. What layers do we have? We have environment, player, enemy attack. We don't need this to be on any layer. We'll just set it to collide with the environment. I do want to modulate it a little darker. Say 150 for these, maybe. And then let's change that to a self-modulate though. So 150, 150, 150. Leave the opacity at full. Oh wait, I gotta go into the sprite. Yeah, 150, 150, 150. And then now we need to add a script to this. So we'll do func. Let's do creation, and then we'll go knock back his position, and I think that's all we need. So we'll do var random starter, let's do random y motion is equal to randy what do we want to do this? Let's say 100. No. How about 20 minus 30? Minus 15 actually, so it's gotta... no, we'll do minus 30. So then I need to make a var motion to vector 2, 0, 0. And we'll make a physics process. Motion is equal to move and slide. Motion vector 2, 0, negative 1. And then here we'll set motion.y is equal to random y motion. And I forgot, I'm going to put randomize. Do Randy. We have no global data. I gotta check that. Our players equal to null. That's it. So we don't actually need this. We can go if global data dot player is not equal to null, then do var knockback direction. We'll just say this knockback x direction because that's all we're adjusting. Then knockback x direction is equal to local global data dot player dot global position dot normalized, and then so that means if the player's to the left of us, it'd be in negative direction. So we want to times that by -1. We'll go randomize. Oh, sorry. Var random knockback speed is equal to randy maybe 20 plus 50, and then motion dot x is equal to knockback x direction times random knockback speed. So let's start out by changing our x motion. So motion dot x, let's go if motion dot x is bigger than 0, motion dot x minus equals 10, but then if motion dot x is smaller than 0, motion dot x is equal to 0. We can do lf motion dot x is smaller than 0, motion dot x plus equals 10 if motion dot x is bigger than 0, motion dot x is equal to 0. What this logic does is that if our motion, basically we check for whether our motion is a positive number or a negative number, and based on that we're gonna reduce it by a certain amount, and I can probably lower this to something like 5. Then after we lower it, we want to check if it's now in the opposite direction of where it was, then we're just gonna set it to 0. So basically it keeps on going down until it gets a little bit past where it needs to go down to, and to the opposite direction, then it just gets set to 0. Now we need to do the y motion, so then we're going to make another variable for gravity speed. I saw player's gravity, I just want to check this for reference. 150. They move pretty slowly down. We're going to set 120. What do we do if I'm going to check something else in our player? Actually, for optimization, just delete both of these, and oh wait, yeah, so then we'll put a negative in front of that 5, and then we'll delete both of these zeros, because it's just like, that way we've just got less lines. Yeah, so it's mostly based on acceleration, this physics. Do I clamp motion.y to something? Yeah. So I'm gonna do this. Oh wait. Let's put this here. And then we also need a max vertical speed now. Which will be 130? No, 110. I'll just make it 100 because that sounds better. So now we'll do if gravity speed is smaller than 180, then gravity speed plus equals 1, and if money ground cast is colliding, then gravity speed is equal to 150. And motion dot y is equal to negative 500, let's say. No, 200. And here we want to do motion dot y plus equals gravity speed times delta. Now, go into our clone, and we make another constant, const enemy mask object is equal to preload enemy mask object, and on our stun time timeout we can go var enemy mask object is equal to enemy mask object dot instance get parent dot add child enemy mask object. Actually, I'll end up moving this, but for now it'll stay here. Enemy mask object dot global position is equal to money dot mask sprite dot global position. Enemy mask object dot creation. I'm going to move this into receive damage when we declare that we are now stunned. We need to set our mask sprite dot visible is equal to false. Okay, so let's test this out. Yeah, didn't expect it to work first try. It's because it's a vector 2, so then can I get a dot x from all that? I don't know. Seems I can. Yeah, so we need to increase that x motion. And the good news is it bounces, and then we want to make it that it can only bounce a certain amount of time still, so here it is. So we're also going to do var bounces left is equal to 2, motion.y times bounces left, change this to negative 50, and I want to increase our random motion y, so change this to random 30, no, we'll keep it at 20, and minus it by 70, no, let's say 90, 100, and then our random back speed, let's change this to 100, change this to 2, both of these. And then we want bounces left minus equals 1. And go and bounces left is bigger than 0. Okay, so the X motion. Oh, maybe we would just right on top of them that first time. Kind of stops abruptly though. Let me change this all the way down to 1. I don't really want it to stop for quite a while. Maybe I'll do if left money groundcast.is colliding, and bounces left is smaller than or equal to 0, then motion dot x is equal to 0, and then here we're going to go motion dot x divide equals by 2.0, and then we'll just delete all of this. I just want to test this a couple more times. Yeah, so similar to how we had that problem with the player with their bounce, we have it so that the mask has a weird bounce that's kind of hard to predict, so we gotta put some constraints onto that. So we go if knockback x motion is bigger than 0, so if it's a positive number, then if knockback x direction is bigger than 0. Is smaller than 0.4, then knockback x direction is equal to 0.4. Changes to 3 actually. And if knockback x direction is bigger than 0.8, knockback x direction is equal to 0.8. Then we'll copy and paste this in a second. Let me just put in an else here. And change this to all of these to negatives. And then we want to change this to bigger than and this to smaller than. Okay, then I'll actually change this to 0.7. Okay, let's see what happens. So it's still a little intense at times. So we change this to 0.6 and this is 0.2. Yeah, in fact, let's change this to 0.1, and this all the way down to 0.4. Yeah, so that's pretty good. And these masks are just gonna be like, they're gonna be bodies basically, because I don't want to use the actual bodies, just because then it can be kind of confusing as to what is able to be possessed and what isn't, because you're not going to be using their masks at all. You're going to be using your skull thing and just taking over their bodies, but we still want a bit of enemy remnants because, you know, it's just cool. And I think this accomplishes the job pretty well. So yeah, we do want to change some stuff though. There's a bit more we want to add in so that it's very clear when an enemy can be possessed. So for starters, if we close this and close this too, let's go into our clone and we'll go into our animation player for them. So when I'm in the stunned, what we're going to do is we're going to grab our body sprite and key in the self-modulate to be white. Every 0.1 seconds, we're going to change it to completely black. Because black is going to be the player's color, so we're never going to use that for another enemy, but so we can be sure that a flashing black enemy will always be someone you can possess. So now what we can do is we can drag our mouse in here and select all of them, and we can right click and do duplicate keys. And just do that again and again. Just gonna grab all of them again though, so it goes a little faster. And I'll just grab a couple now. Yeah, so let's see. I believe that's good. On some of the brighter enemies, it might be a little jarring though. So yeah, sorry, we're gonna have to delete all of this. I'm just gonna space these out to 0.2. Let me just have a look at this preview so I don't make the same mistake. Yeah, that'll be fine. Just make sure you go 0.2 seconds, not 0.1. So that's 2 keys ahead of the last one. Okay, so now we're going to create a new scene. We're going to add a sprite as our root node, and we're going to rename this to can possess effect, and we need to add an animation player, and that's it for the nodes. And click on our effects and drag in another sprite, or you should hopefully already have it. And or if you're following from when this tutorial is already released, it should hopefully already be in here. You can drag it in, and how many frames do we have? 1, 2, 3, 4, 5, 6 each frames, and 1, 2, 3, 4, 5 B frames. Save this under effects, yeah, and then we'll do new animation, and we're going to call this can possess effect. And how many frames do we have in total? Just go with something like 30. That should be pretty much our max. So we have 28 frames total. Let me bring up the calculator. And we want this animation to be 1 second. So we divide 1 by 28. 0.035 is going to be our animation time. And key this frame. Move up by 1. Oh wait, I need to. It's the wrong frame to key first. Reset the frames. Key that 1. Spam that button. Okay. I'm just gonna drag over these. Move them forward 1. And then we'll change this to, no, I want to keep that 1. I'll Control Z that. So this is our short animation, and the reason why we're doing it 1 second is because we're going to make it that way. It's easy to modify the playback speed to make it how long we really want it to be, the animation player. I don't know if I've explained the playback speed yet, but essentially it's like the speed that this goes. So if it's at 1 and our animation is 1 second, this happens in 1 second. If it's at 2 and we play our animation, it happens in half a second. If it's at 0.5 and it happens in 2 seconds. And you can do negative numbers, but they really just mess it up, so you know, don't. So we're changing our snap to 0.1, so we can add a call method track for this. Insert key Q3. We need to add a script to this, and I'm gonna go creation, playback, speed, and then any animation player dot playback speed is equal to playback speed. I'm gonna add a Y in there because I seem to make a bunch of spelling mistakes whenever I start recording. And now we can go into this. I just want to reset the frames, and we'll do money animation player dot play can't possess effect. Is that what I named it? Did. It's a bit of a weird name, but I don't feel like changing it. So go into the clone, and then underneath our large melee, we'll do const can possess effect is equal to preload can possess effect.tscn. Always remember to make sure this is at the end of it. So in not our stun timeout, when we first start our stunts and receive damage, we want to do, I will do it right here, so we'll do var can possess effect equal to, is that 3 S's? It is. Yeah. Can possess effect dot instance. We'll do self dot add child can possess effect. Can possess effect dot position minus equals 6, let's say, and can possess effect dot creation. Here we'll do 1.0 divided by stun time dot wait time. Since I'm not entirely sure what our stun time will be, this will make it that it will be a slower time because we need it to be decimals to play slower. So it'll be a slower time of whatever our stun time is this map will do it correctly. Pretty simple stuff. Yeah, that way we can just, I don't want anything where, I want to just be able to adjust this without going through the script a bunch. So, now let's check if the effect works. Does not. Forgot to do .y. Okay. Yeah, so then as soon as that timed out, then that'll go away. That's just, you know, so that it's very clear that we've got something to possess over here. And the different types of enemies will be kind of hard for the player to keep track of, actually. So I might actually want to adjust the clone's stunned animation. Again, I'm sorry. We'll make it that. Move this along. Let me delete these. And I want to duplicate this. And this one more. Two more. Yeah. Let me see how that looks like. Actually, I gotta duplicate this again. Yeah, I think that'll be good. So then, let's delete this frame, grab these three, and we'll want to do this 2 keyframes afterwards, and we can duplicate it. Do that a couple times. That I mean 2 times, and then we can duplicate it some more. Okay, so quick look at this. Yeah, because it's mostly the different enemies are gonna have different abilities that you can get by possessing them, and then it's basically just gonna be the color of them though, for how you can tell them apart. Yeah, so that works pretty good. We've got all the effects set up to make it clear what we can and can't do, and still a lot to do. Like, we gotta make it that the player can self-destruct their body, and then they can use their mask to take another body, and then after that, then we gotta make it so that the player can choose which enemy they possess. I'm going to do that by basically making it that then after self-destructing, the player's mask kind of floats there, and they can shoot it in a direction and time will kind of stop until they do. And if they end up missing an enemy, then that's gonna be on them and they're gonna die. And if they hit an enemy though that's stunned, then they possess them. So now it's also like you can't just possess anyone, you have to be in line of sight, which I think should make some interesting gameplay. Hopefully it's not a pain in the ass. Yeah, after that, we're basically just gonna be changing the player's body color, and then we are going to have it so that and then we're gonna have like some stuff that checks what exactly, basically what our body color is, and we won't check that specifically. We'll have like some sort of variable that keeps track of what type of enemy we're possessing, and that'll decide our body color, as well as any abilities we might unlock, and health maybe as well, blah blah blah, all that stuff. There's still a fair amount to do. Hopefully that stuff's pretty quick though, and it's more just gonna take time for me to make some animations. So yeah, that's it for this video. I hope you enjoyed and learned some stuff. So if you want to learn more, then consider subscribing. I'll be making more videos to this, as I've previously stated during this video. And any likes or subscriptions I get motivate me a bit more to make stuff more often. So if you want to see stuff more often, then do that. That'll be it for this video, and have a good day.